Normal distribution is the way that large amounts of data are distributed. Graphically, it looks like this. This is known as the normal curve or the bell curve. But what happens is most of the data congregates right towards the middle here. And this is the mean. Then, as we move away from the mean, there's less and less pieces of data. These marks that we have here represent standard deviations. So if we go out 1, then that means we're adding 1 standard deviation. If we go out 2, we're adding 2 standard deviations and 3 standard deviations. As we move to the left of the mean, that'd be taking the mean and subtracting a standard deviation, or subtracting 2 standard deviations or 3 standard deviations. The amazing thing about this is that when we're dealing with large amounts of data, that data congregates in the same way when there's a lot of data. And how that happens is if we go within 1 standard deviation right here, the funny thing is 68% of the data is going to be right there. If we go out 2 standard deviations away, so including that 68% plus this stuff on the sides, that's going to give us 95% of the data. And if we go out 3 standard deviations, so that 95 plus the stuff on the end over here, that's going to give us 99.7% of the data. Now there is still a little room for those extremely rare cases where a data is very low or very high, but the funny thing is that when you're dealing with large amounts of data, 99.7% of the data is within 3 standard deviations. A more complete and nice looking chart is right here. You might want to pause the video for a minute and copy this normal bell curve down. And you notice that what we have here is our 68% landing within 1 standard deviation. There's our 95% landing within 2 standard deviations, and 97% within 3 standard deviations. But the other thing is that there is symmetry. For instance, within this first standard deviation right here, since there's 68% of the data, that means that half of it, 34%, has to be within 1 standard deviation below the mean, and the other 34% has to lie within 1 standard deviation above the mean. When we move on to the next interval here, going within 2 standard deviations, remember we get 95% of the data. We've already used 68% of that data, and that leaves us with 27% left, and that percent has to get split up on either side equally, and so each of those intervals has 13.5%. And the same thing happens here, and that's how we'll get 2.15, and then 0.13 being in the extreme values beyond 3 standard deviations away. But like I said, you should write this down. Take a second, copy it in your notebook, all right? Get pretty comfortable with it, because the types of problems that we're going to use involve an intimate knowledge of this chart. For instance, a piece of data is selected randomly from a normally distributed data set. Find each probability. And when we look at this, what this is saying is the probability that X, our data set, is between X bar and X bar plus 2 sigma. All right. Basically, what's the probability that our data point is going to be between the mean and 2 standard deviations above the mean? We'll take a look over at our chart. Here's our mean, and here's 2 standard deviations above the mean. Well, there's 34% right here and 13.5% right there. That means that this probability is just going to be 34 plus 13.5. When we add those together, you get 47.5% probability. The next one here says that X is between X minus a standard deviation and X plus a standard deviation from the mean. So we started our mean. We're going to go down 1 standard deviation and up 2 standard deviations. So what's going to be the total probability? Just add those two together. 34 and 34 and that 13.5. Adding all in, that's 68 plus 13.5, which is 81.5%. Let's do one more. What's the probability that x is less than the mean minus 3 standard deviations? So here's the mean, and here's 3 standard deviations. We want to be less than that, which is just the 0.13% probability. Remember, where that came from is 3 standard deviations away. So from here to here, all of this makes 99.7%. So if we took 100 and minus 99.7, we're left with 0.3%. And that 0.3 gets split up below 3 standard deviations below and above 3 standard deviations above the mean. Which, if we added these two up, you're like, but Mr. Tell, that only makes 0.26. Well, guess what? That kind of rounds to 0.3. But using our table here, we'll just use that 0.13 to get our percent. We will run into problems like this. It's just talked about a data set. Cholesterol readings of a large group of women is normally distributed about a mean of 172. And the standard deviation is 14. Now the question is, what percentage of those women have readings between 158 and 186? Now, what you should do is just quickly sketch a normal curve. So here, I've just grabbed one off the internet, and let's start filling it in. For instance, we know that the mean, it says, is 172, so that's got to be in the middle. And the standard deviation is 14, so every one of these extra marks that we go out, we should be adding 14. So now we're up to 186, and 200, and 214. As we move to the left of the mean, we should be subtracting that 14. So that would make 158, 144, and 130. Now, back to the question. What percentage of the women have readings between 158 and 186? Well, that's 1 standard deviation on either side of the mean. So, 1 standard deviation on either side makes 68%. And what percentage of the women have readings above 200%? Well, let me clean up my picture a little bit here. Right, it's not above 200%, it's above 200. So we want to know how much is over here. Well, from here to here, this is 1, 2 standard deviations on either side of the mean. Okay? 2 standard deviations mean that between 144 and 200, that takes care of 95% of the data. So how much is left over? Well, that means if we took 100 minus 95, we're left with 5%. And that 5% has to be split up evenly between both sides. So divide that in half, and we'll have 2.5% of the data will be above 200. So get used to the normal curve and understand the percentages, and that'll help you through most any one of these problems.